Hello. I'm glad that everyone made it back from the pause and from the group photo. Um, yeah, so we're going to talk about the KVM backend in VirtualBox. This is Martin. I'm Julian. There we go. Two disclaimers before we start with the content. VirtualBox is a trademark owned by Oracle. We are not Oracle. We also have no affiliation with Oracle. And the second trademark is that this is teamwork with Thomas Prescher and Stefan Kober and Sebastian Eidam. I think he also did stuff, Virt.io. And many other colleagues at Cyberus, and we are just the lucky ones that got to present here. What are we going to talk about? Super quick introduction what Cyberus is. We're going to talk about why we did this. Then I will hand it over to Martin for all the cool technical low-level things. And then our talk will be over. So who's Cyberus Technology? For those of you that we didn't meet in the bar and told this before, so we're like a tiny company in Dresden with 25 people. We currently do lots of things in the realm of Cloud Hypervisor, VirtualBox, KVM. We like to use NixOS, we like to use Rust. So if any of this seems interesting to you, come find us afterwards. Then, if you're wondering how we test all of this virtualization code that we write, there was a talk yesterday by these fine gentlemen over there about testing. It's also worth watching. Okay, with that, what is VirtualBox? VirtualBox is a user-friendly virtualization software that has broad host and guest operating system support. VirtualBox runs on Windows, Linux. It may run on Solaris as well, at least it used to. Also, inside of VirtualBox, you can run everything from DOS to Linux to modern Windows 11 guest. It has all the nice features that you want to use in a desktop virtualization product. It has dynamic display resizing, clipboard integration, shared folders. You can drag and drop files. And in general, it's a really nice out-of-the-box experience. And this is also why it still has a lot of users. Especially non-technical users like to use VirtualBox, and it's in surprisingly many products where you wouldn't think it is in. Here, lots of people use Qemu, libvirt, and maybe also GNOME boxes. And you may ask, what's the relationship between all of this? So in general, if you use the stack on the left, you get basically the same experience as in VirtualBox. You just have to piece it together out of many different projects, and so there's like the bazaar style of development, and VirtualBox is more like the cathedral, one huge repository with everything, and it works without fiddling. So far, lots of positive things about VirtualBox. So why are we even doing something in this area? So since VirtualBox is pretty old, they actually started out with their own hypervisor. They ship a third-party kernel module that implements the whole VMX stuff and AMD virtualization. This has historically had quality issues, so you can find people ranting about it on the Linux kernel mailing list. It is very different from KVM, how it works. So basically, VirtualBox uploads a lot of code into the kernel that also can do lots of emulation code directly in the kernel. This is not something you would design like this anymore. And of course, the main downside is that you can't use it together with KVM. And KVM, people want to use KVM. The other thing is, since it is a third-party kernel module, you have to use DKMS or some other horrible technology to use it. This is annoying for users, but also for distros, and in general, you don't want to have this. So what you want to have is basically the VirtualBox user experience, but without all the hassle of custom third-party hypervisor. This is obviously where KVM comes in. KVM is a really great fit for VirtualBox. It has many features that VirtualBox does not have, for example, all the modern interrupt virtualization features like APIC-V and AVIC. KVM has all of those. KVM has a way more complete set of Hyper-V enlightenments to make Windows guests fast. It has a pretty robust security story, maybe not perfect, but definitely better than the VirtualBox hypervisor. And of course, KVM just chips in all the Linux distros. It's just there. So, and this means that if you are someone who likes to use hardening patches like GR-Security packs, you will have no problem if you use KVM and you are in a world of hurt if you want to use the VirtualBox hypervisor. And now the question is, how do we marry the two worlds, VirtualBox and KVM? So VirtualBox already has multiple backend types. So Oracle has discovered that also on other platforms, it's really nice to be able to use the native virtualization API. So in addition to their original hypervisor backend, the HM, they introduced like the native execution manager in the codebase. And this is what enables VirtualBox to use the default hypervisor of a platform. And they have like proof of concept NEM backends in the codebase for Hyper-V, macOS, and KVM. But the KVM one is incomplete and broken. So you cannot enable it. You would have to fiddle in the makefiles, I think, to enable it, and then it will just not work. So what we did, obviously, is we set out to fix it. We started last year. If we had a longer talk slot, we could talk about all the amazing things that we did. So we fixed the interrupt handling in it. We fixed the timeout, the timing handling in it. Then it started working, and then we went to the cool stuff. So we made it use the split IRQ chip. We made it use split IRQ chip in KVM for performance, and we also enabled all the KVM Hyper-V enlightenments for VirtualBox, so Windows VMs run really nicely. But one of the major issues we had is we also tried to enable virtualization, nested virtualization support. And initially we thought, well, we tell KVM to turn on the VMX CPU ID bit and we do some VMX MSR whitelisting, and there we go, nested virtualization. But this turned out to be a somewhat longer story with some interesting bugs. And for this, I will hand over to you.
Thanks, Julian. Yeah, initially we try to just enable VMXE and the CPU VMX flag and some MSRs. And actually, Linux works in Linux. So this was the easy part. But we also have Windows. So, but before we start the deep dive, let's talk about the terminology again. When it comes to nesting, we have a guest, which is called in our talk level 1 guest, and the one which is booted inside the VM is the level 2 guest. So now let's start with a deep dive. Ooh. Can you? Yeah, thank you. Now the issue. In certain scenarios, we get with the level 2 hypervisor the issue that the Windows VM crashes with the kernel mode exception. Actually, after some debugging, we found that the main issue started in the TLB flush routine of the global page tables, especially at the instruction move CR to rex, move rex to CR. Sorry. There caused a general protection fault. So what we then we after finding this, we investigated deeper and deeper and just used our own guest tests. Did test suites that we used for our own hypervisor when we developed it some years ago, and now we have restarted it and re-implemented a new test that just checks the values for CR4 in the level 2 hypervisor, level 2 guest, sorry. And yeah, this is what we have done then. We found the root cause. In certain scenarios, when we run the VM a while, we discovered that the CR4 value changes out of the blue. We don't even know what is going on there. So what we've done is that we use signals to interrupt the level 2 and level 1 hypervisor to deliver timing events and device interrupts and something else. And what we found is that after some exit, which is caused when the level 2 hypervisors, level 2 guest is run, the KVM in the KVM run register, KVM run struct is the level 2 state. That means that, in our case, also we mark control register values as dirty every time we enter the guest, because we thought that it's inefficient, okay, but it should work in the meantime. So, but this is not the case. In the case of KVM, it is that way that if we get a VM exit in the level 2 in level 2 hypervisor guest, then we just have also the register state of level 2 in the KVM run struct. And we doesn't even know that, so we just write the other value of the level 1 value of CR4 again to the SREX. And actually this caused the general protection fault, because at this case we enable CR4 VMXE, so we enabled VMX for the level 2 guest, and this causes a general protection fault. Also, we have after finding this issue, we also have seen such issues in Qemu. We have a ticket for that.
Maybe a quick. So I filed this bug in Qemu like 2 days ago. So in Qemu you can trigger the same issue with safe VM. It's really weird. So if someone wants to talk about it afterwards, it's a good topic.
All right. Okay, how did we solve this issue? At first, we looked at the Qemu code and checked whether it could be an issue. So, and we afterwards just marked not the control register value is not dirty anymore, and just change it if they really change. And this helped us a lot, and we could get working Windows in Windows. Yeah, but from our perspective, this is just a workaround, not the real fix. So we submitted a patch where we fixed the behavior which got rejected, but enabled really good discussion on the mailing list, on the KVM mailing list. And we got supposed to get a new solution for that, which was the addition of a new flag in the KVM run struct, which indicates the execution level, which is basically the guest which is executed in right now. Okay, this one is also submitted to the mailing list, and we were able to get it merged. And it will be available with Linux 6.11, which is released right now, I guess. So yeah, but what does it help for in our situation? When we know which layer is executed at the moment at a singular queues, we can detect which state we can write to the KVM run struct to circumvent those issues. And this is so not this should work like that the next time. Okay, our takeaways. For us, it was the first really large project after years which we don't work with KVM, and because we have worked with other virtualization APIs. So what our finding was is that for us it was a bit hard to find the documentation, or we even have to look up Qemu and KVM source code to understand what actually is going on when we ported VirtualBox KVM to this backend, the KVM backend for VirtualBox. And also there are some assumptions we made which are violated. what I mean is that marking unchanged values as dirty and just writing it back, it should be a no-op from. That was our assumption, but yeah, this wasn't the case. Also, we had another with the Lepic code. I haven't detail.
Yeah, so if for debugging, you just call from a random thread KVM get Lepic. This leads to interrupts being lost, which is super unintuitive. So you would assume that if a IO control is called get some state, that is actually not mutating that state, but this is not true. And this has made some debugging sessions more complicated than they could have been.
Yeah, but yeah, we want to improve that, I guess. So a question to the might be afterwards after the session. How can we improve this? Can we write some documentation for others? They want to change. They want to add the KVM to another VMM, or even is there a way to simplify the APIs? So yeah, let's talk. Let's talk. Okay, but yeah, I told now we have the solution for Windows and it works pretty well. Also, the performance is competitive to native VirtualBox. We just tested it against Qemu right now. No, we don't. And yeah, what we support is we have tested it on AMD laptops, AMD servers, and Intel CPUs. The nesting works for Intel, and we have also implemented a virtual GPU and VFIO support in VirtualBox, so that we can pass through Intel SIOV enabled GPUs up to the Intel Xe GPUs, especially from Alder Lake and newer. So yeah, also almost all VirtualBox convenience features like shared clipboard or the guest integration itself works with the KVM backend as well. There are some minor integrations that won't work, but we are open if someone gives us the money to help with the development to enable this as well. So now I give back to Julian.
Thanks, Martin. Yeah, so if you're interested, we blogged about our endeavor, so you can go to our company blog. There are a couple of blog posts. If we do something else, we'll probably blog more about it as well. This has been actually pretty fun, the whole project. It's also nice because we can write about it and it's not confidential or anything. Yeah, this was already it. Yeah, okay, this was already it. So in summary, we have a patch set for VirtualBox that adds a KVM backend to it. It just works. It's really nice. I use it as a daily driver. So if I had more hands, this was the wrong one. If I had more hands, I can just click on it. Thanks. You see that this also is a PowerPoint that runs in VirtualBox on my laptop, and you can also just next to it start some Qemu stuff in it, so it works. It's all on GitHub. You can find it on GitHub. It has a sponsor button, so at the moment we do this for our own entertainment and for our own usage. But in case you find this useful, or one of your relatives, if you have some relatives that need a user-friendly virtualization tool, definitely use it. Other than that, the KVM API works, but is a bit for the brave. So if you come to it not knowing the details, be prepared to read Qemu code, to read KVM code, try to understand it. I think we still haven't understood how control register stuff works in nested virtualization. I think Sean does, and I'm very grateful for it. We're super happy to be constructive about it. So we're not. We understand where this comes from. It's all, I mean, historically grown. But we're eager to help in any case that people point us to. For using this, we have packages. There are some super motivated maintainers that have packaged this. You can use it on NixOS, Arch, Linux, Gentoo. There's probably some Ubuntu PPA somewhere. And there's commercial support if you need it for VirtualBox, for Cloud Hypervisor. We do Nix and NixOS stuff, and of course, testing. Yeah, just get in touch with us. And this is it from the presentation, and now we're happy to take questions. I think we have quite some time for questions.
Can you elaborate on the non-atomic PIR to IRR sync? What part of it is non-atomic that you don't like?
There's some hidden state that gets synced to the interrupt to the IRR register. And if you call this from a different thread, and on another thread there's an interrupt signaled, I think there's a chance of interrupts being lost. And this is, I mean, in a sense, this is okay. That this happens because in the hardware it also works like this. You cannot just fiddle with the register atomically, but I think this should be spelled out in the documentation somehow, like don't call this from another thread. If you want to know more details, I can connect you to Thomas I mentioned before, who's probably happy to explain you the details.
Can you post on list the gory details of exactly what is broken or what you think is broken?
I think it's not broken, it's just very surprising that this happens.
Even if it's just surprising, like if it's broken from the perspective of you read this and this is idiotic from what you think should happen, just post on list and we can go from there. And
awesome, yeah.
I mean, worst case scenario, we add documentation and say, yeah, here be dragons, this is a stupid API, but...
Yeah, sure.
When you said that you had to look in the code, that means that the in-kernel documentation was in no way sufficient or useful for you, or?
Yes. So I think to know how to use the interrupt code and the event injection stuff, you just have to read Qemu code and see what Qemu does. If in doubt, do it like Qemu and you're happy.
Because that would be the natural place. If you really want to add documentation, that would documentation word that folder. But or at least tell us which parts of this documentation sucks. And I know a lot of things.
I think the most valuable would be overview documentation. So like, hey, you want to write a VMM, you will have to inject interrupts. Do this, use these 5 I/O controls, ignore all the other stuff that exists, but do not touch it.
So some kind of hypervisor for dummies in 10 steps, whatever.
Yes, and probably it exists somewhere, the reference code, and it would be nice to point people to it. Yeah. I think for the nested virtualization semantics, I think I would say from the documentation, we were just lost. And I'm pretty sure that for VMX, all the VMMs that are out there don't handle this correctly in edge cases.
And second question, when you said about the control register mix-up, was that using the sync-reg feature, or what was? Where did you have the dirty flags set? Was it sync-regs?
In the KVM run sort. Yes.
Okay.
Yeah, the dirty regs problem was they were setting the sync regs, telling KVM to refresh the CRs on every VM run, every KVM run. But they were doing it using the L1 values. And so if you took an exit to userspace while L2 was active, then they jammed in L1 CRs into L2 because they were setting the flag all the time.
The question is this something that we should fix in KVM?
No, this is userspace, don't shove L1 state into L2.
Yeah, but then the question was, how do you find out that it's actually L2? And if you actually want to change something, how do you get control back if L2 exits to L1?
So I don't know, that might be, I don't know the details of x86, but on the SM90 part, when you exit user space, you always get the host register parts, and the guest values are completely hidden away from user space.
Yeah, the problem is x86 doesn't have a clean split where you have virtual registers for things. Especially when you get into nested, yeah, you have to, the things allow you to just save out what the state is. And it doesn't, there is no, it's resident in memory somewhere, but that's not the CPU state, and all of KVM octals work on what the actual current CPU state is. And so when you read out registers, when you set registers, you are setting for the current state, and that happened to be L2, but you use L1 values and you blow up. And so really it was the lack of a way for userspace to know L2 is active without having to make another syscall just to know L2 is active. So chuck a flag into the run structure.
In that particular case, you were running the sync regs, right? So you just use the KVM run synchronization registers. Why was the wrong CR4 registers in the sync regs when you got out into user space? At that point, you should have synced the level 2 CR into your in-user space representation, and then when you go back, you can set it dirty as much as you want, but it would be the dirty value of L2.
I think we should talk about it offline, but we just wrote back what is in the CR4. We just marked it dirty, so we didn't change the value. It was just the value that was in the KVM.
They weren't setting the the user space was broken because they were just setting the sync reg bits. They weren't actually refreshing the values that were in the KVM run fields that KVM was consuming. They were just setting the bit. So the way Qemu does this, Qemu doesn't, I don't even think Qemu uses set regs or sync regs. They just do all the octals. But the way Qemu does this is it keeps track if anything in Qemu has dirtied CPU state. And so the only time that Qemu actually sets CPU state is when it needs to. This was setting it every time because it was cheap, and then you shoot yourself.
With the caveat that Qemu also doesn't get this right, and you can reproduce the same issue.
SyncRegs should go both ways, right? SyncRegs also synchronizes them into the KVM1 state when it goes up into user space.
Yes, they are in there. So you see the correct CR4, and if you mark it dirty, then magically the wrong bit pops
so you probably just stumbled over a bug where the push to user space didn't work correctly.
So maybe a different answer here is that the complexity of x86 is not really reflected in the API. So in other APIs, you can just set the CR4 read shadow yourself, and it's the VMM's responsibility to set something sane in there, and you have all the complexity exposed to user space. And in KVM, it's a bit difficult to figure out how you should hold it.
Maybe a last question. Is there any chance or plans to get something back to the VirtualBox project or that code where you got your initial code from?
I think this is up to Oracle.
Which means no, maybe?
This is up to Oracle.
So the VirtualBox project is not too actively maintained by Oracle. So is there any plan like you have this KVM backend like to maintain further, or what is your future plan?
So at the moment we will maintain it further. We don't have a lot of resources to spend on it. So as long as it's just rebasing it to the newer VirtualBox version and sending it through our test stack and publishing a new release, we're probably going to continue this for a while. If too much changes in VirtualBox and we would have to touch bigger parts of it, we have to see. So because at the moment there's not a lot of commercial interest in this, so basically doing this as a side project.
Thank you.